Alright, so welcome back again. My name is Jesse, and in this wonderful tutorial we're trying to do a simple unsupervised machine learning using the very nice package called PyCaret. So in the previous tutorial we saw how to use scikit-learn to do unsupervised machine learning. So in this particular tutorial we're trying to see how to use PyCaret to do clustering. So we'll be tackling the same problem that we did previously about the data that we had from Google. So let's check that data that we had, which was this particular dataset that we had, right? Which we're trying to see how to use unsupervised machine learning to help us label these things or cluster these particular latitude and longitude, the countries, into their respective continents. So let's see how to do that using PyCaret. So I just come back here. So PyCaret, as we already know, is an open source low code machine learning library which was developed by Moaz Ali and co. He's a lead developer. He's a creator of this particular powerful package. Very interesting guy. Now let's see how to work with it. So we're working from Colab, and then let's understand the basic workflow when trying to work with the clustering aspect of PyCaret. So the basic understanding is that you just have to prep your data, then you're going to initialize your setup, right? So initializing your setup, that's when you're going to define the particular type of data, what you want to do, the columns you want to ignore, whether you want to normalize it or not normalize it, right? Or standardize them, which is very interesting. Then you can create your model, and after creating your model, you select the particular model that you want. So there are several clustering algorithms that you can use in this particular option. Then later you're going to assign your model. So assigning your model means that you are adding the clusters to the dataset. You are trying to add the clusters to the dataset to actually label them, right? To put them in the right place. So that is the big understanding. It's supposed to be, I spelled it wrong. It's supposed to be TH, right? That is the big understanding. Then after that, you're going to check the accuracy of your model, then you can tune your model, you can save your model, then you can make some predictions. So let's start working with it. So we'll be starting from scratch. That's what we're trying to do. So let's go back. Right, so let's start. So we'll be loading our almighty pandas. So we'll be importing pandas as PD, and we'll be importing our our data visualization packages such as matplotlib. So these are the main ones that we'll be using in this particular tutorial. So it's going to take some time to load. Then you're going to also load matplotlib. So it's loading perfectly. I hope everybody can see the code. Perfect. So now let's load our file. So our file is the one we already used in the previous tutorial. So let's load the same thing. So we're using Colab. So from Google.colab import files, then I'm going to run this particular code to load or upload our dataset, right? It's going to take some time for it to load. Then go to choose file. I'm going to choose a particular file. So this is the dataset that you're using, right? Coordinates of the countries. I'll pass it there. It's going to upload it, taking some time to save. Perfect. So that's finished. Now we can load it. So let's first of all see what we'll be doing. So this is going to be our final task. After doing everything, we're going to check and see if our clustering was perfect. So let's load our dataset and make it a little bit bigger so everybody can see, right? So load dataset. So it's going to be df pd.read _ csv. Then we are loading our countries coordinate dataset. So countries, right, _ coordinate. So this particular dataset that we had, the same thing that we had here, that's what they're trying to load. So I'll copy this one, then we will load it perfectly. Right, so let's name it well. Right, so let's read it. So we're going to read our dataset. Perfect. So if I check it, our dataset is actually read well. Perfect. Right, so you can see that we have our countries, our latitude, longitude, and our name. So let's see. This is something very basic, so we'll not be going more into EDA, we'll just be going straight away to the clustering. So in trying to, the next step, as we learned in our workflow, is that we want to be able to initialize our setup. Then we're going to create our model, assign our model, and then move on. So setup, C, right, you set up, you create your model, you assign your model, then you do the rest. So let's first of all see how to work with it. So we'll be trying to initialize. Let's bring it here. With this option, we're going to initialize setup, right? So in that case, we'll be using PyCaret. So in case you're not installed, you can install it with this option. So first of all, let's install it on our system. So pip install PyCaret. We are using Colab, right? For it to be faster, it's going to take some time for you to install all the various packages. Then after that time, after that's finished installing, we are going to go with this. So from, we can just go straight away with this option. It's taking some time for it to install, but whilst it's installing, let's write our code. It's going to be import PyCaret.cluster. Right, that's finished installing perfectly. So clustering as PC, we are installing it as PC, right? So we are importing PyCaret.clustering as PC, and let's see the various things the various methods and an attribute. I prefer it in this way to make it easy for us. So if I go with our PC, it's going to list everything perfectly for us. So perfect. So we can assign model, you can create model, deploy model, you can get clusters, you can load experiment, that is your workspace, you can load model, plus model, predict, and do some interesting stuff. You can even tune model. So let's check it out. So first of all, we're going to do our setup. Then after doing our setup, we are going to create our models using k-means, right, for this tutorial to help us with our tasks. So let's check it out. So our task is to segment. The task we are trying to do is that we are trying to segment countries, right, into their respective continents using clustering, right? That is basic. I understand basic target you are trying to do. So I just come back to the same place and then I'm going to initialize it. Init. So we'll be initializing setup is going to be pc.setup, right? Now passing my data frame. So I'll go with df for data frame that we have. Then if you look at here, you can see categoricals, different parameters, different keywords that you can use, right? So in this case, we are going to ignore some columns. If you check back from what we did earlier on, let's go back and see some of our columns are just names, right? So if I go back far, some of them is just test. So the country, we don't need it, we don't need this one, we don't need this one, so we'll be ignoring these ones and this one, and we'll left it only the latitude and the longitude because that's the only numerical value there, right? So we'll be ignoring them when you are setting up initially. You can use them, but let's ignore them from scratch. So let's come back here. Then it's going to be this, right? So the data, then the features I want to ignore is ignore. Let's go with this option, ignore, right? We are ignoring these ones. So see that we have several ones. We have ignore, right? Ignore low frequency. We have also another one here. So we just go back and then we just go ignore. No, we're not running it. Ignore feature, right? Then the features we are ignoring the country column, and you're also ignoring the name. So these are the main ones we are ignoring. They're going to initialize it and create our setup. It's going to analyze it. So it's going to ask us some questions. We're just going to go with yes, right? Going to analyze them perfectly for us and give us our result in a very nice format for us, right? Very, very cool. So that is one of the ways, and you can see that from here it's giving us some information. This thing that we did, we can also store it inside a particular variable to make it look nicer, right? So this is something very nice, right? We can, let's change the look to make it beautiful, at least so that everybody can see it well. Okay, let's maintain it like that. Later on we will change it, right? I think it's okay. Okay, perfect. So I can actually store this one inside a particular variable. So let's call it as I give it any name. So look at any name that I want. So CLS, right? Clustering. Then now in this case, it's going to give it to us in a very nice beta format, right? So it's going to ask the same question. Then just all of them are numeric. Then just go with yes. Then it's going to analyze them and then give us in a nice format. So you can see from our data set, from the result that's given to us, that there are no missing values. There's some missing values there, numerical values. There are 2 categorical values, 2 some interesting information. Now let's move on to the next stuff we'll be doing. So we have set up our place. Now let's create our model. So this is going to be our create the model. So we just go with same thing. So let's call it as k-means model. Then I'll just go straight away with this PC for PyCaret.clustering, right? Then I'll just go straight away to create model. So this option, create model. Then now it's going to create the particular model. So here I can specify the particular model that I want to use. So let's use k-means model, which is going to be k-means, right? Perfect. That is all that we need, right? So we can specify in this place, we can specify the particular number of clusters we want to use, which is, let's go to the number of clusters. So here we have number of clusters there, number of clusters. So we already know that if we are grouping countries, right, into their continent, there's going to be either 6 or 7 continents. So we can actually specify, as we did previously, the number of clusters as 7, right, because we have 7 continents. So it's going to use k-means, then it's going to analyze perfectly for us. So now just build our model in a very nice format for us. So if I go back and I just check the km again, the k-means model that is created, it's going to give us some simple details. So this is the algorithm, and this is the number of classes it's using, right? Very simple and very nice. Now we can also do some other stuff, like we can actually assign the model, or we can even plot these things, right? We can do some simple plots of it. So we can actually come back here, can actually do a simple plot. So we can just do an elbow plot. So there's going to be an elbow plot. So the elbow plot is to help us to know which of the, it help us with to find, right, to find the optimal cluster number, right? That's the basic understanding behind the elbow plot. So you can just go with pc.plot model, right? Then I'll just pass in the model that we had, so it was km. So if I go with km, by default it's going to use the normal cluster, but because this is the data set is in a different format, it's going to give us an empty stuff. So we can just give it a particular plot, which in this case we are using elbow plot, so we just go with elbow, right? That is a big understanding. So if I go with this, it's going to generate an elbow plot out of the box for us based on our model, which is very interesting. So based on our model, what we had, the best plots, the best number of cluster here is 4, right? But we are using 7, right? We initialize with the 7, but it is giving us as 4. That means that 4 is the best way for us based on this particular model, except we tune it. But let's leave it at the 7. We can also do some other plots like silhouette plots, which is also does the same function above us, helping us to find the optimal number of clusters, right, as well as the silhouette score, all of them together. So we can just come back to the same place and do the same thing. So I just come back here, then pc.plot, then I'll pass in my model, then I'll pass in the plot type that I want to plot, then I'll give it what I want to, which is going to be silo, right? Going to analyze it and give us our silhouette plot. Perfect, very interesting. So this is giving us 7 clusters, right? So 1 2 3 4 5 6 7, and you can see that some of them are not the same shape. So in reading the silhouette plot, as we learned previously, we are checking for the thickness of the silhouette, as well as how each of these silhouettes extend beyond the silhouette score, right? If they extend beyond it, that means that it's good, right? If it doesn't reach this line, that means that is not that good, right? But this is all good for the 7 clusters, but some of them, the thickness is so small because some of the continents are like bigger than others, of course, so it will make sense in that way. That's one of the plots you can also do. You can also do some other plots. So let's try some other plots you can also do apart from these ones. You can do a simple distribution plot or a scatter plot, but in this case, if you do a scatter plot, this is going to be a scatter plot. It's not going to give us any result. So pc.plot model, and I pass in my km, right? If I go with cluster, the plot is going to be go to cluster, right? It's not going to give us any plot. It's going to be empty, right? It's empty, right, based on this particular data set. But we can, in case you were using a different stuff, you could have used that one. You could have used this one. It's going to work, right? You can also do some distribution plots. So let's try that one for this. So let's comment this one out because it did not give us any plots. So you can also check for distribution plots, which is going to be this option. So this is going to be a simple distribution plot for everything. So let's call it as distribution based on our data set. So in that case, I'm going to change the plot to distribution, right? So distribution, and then here you can also specify the particular feature that you want to get out for. If I go with this option, it's going to generate a distribution plot. If there's nothing, it's not give us anything, right? I think there's something wrong with the kind of data set we have, but I can also specify the feature. Then let's give it a particular column. So we are using the latitude, right? Latitude. Let's see whether it's able to generate something for us. It was still not able to generate. So in a normal way, in case you are doing something, you just do it, the distribution plot, it will work. If you are working on let's say a normal plot, right, it's going to work. Well, this particular type of data that we have, the only one that we could generate was the able plot, right, to help us identify the number of clusters that we need. And then we also had the silhouette plot to help us to know the number of clusters that we need. And then it makes sense, right? But the rest you can also do that, and it's going to work on a different data set. So let's move on to some other stuff you can also do. So we have been able to see how to, first of all, create a model. We have seen how to set up. Now let's see how to assign our model to the right place. One last plot we can also do apart from this. If this is not working, you can also try one last plot, which in this case is going to be our distance, right, to check the distance between them. So in that case, it's going to be this option. So this is going to be something we'll be trying to predict later on. So this is going to be a distance plot. Apologies for the noise behind, if you are hearing any noise behind. Okay, so it's going to be this. It's going to be our distance plot, right? So I'll change this one from here to distance. So distance. Then let's take off the feature. We don't need this one. Right, so if I run this one, now it's going to create a distance plot for us, right? Very interesting. So based on the 7 clusters that we had, right? Very interesting. So there's one cluster here, which I'm sure this one is due to maybe Antarctica, right? Then we have the different places. Very interesting and very cool. So let's see how to assign our values, right? So you can just go with assign our clusters to their respective data, right? So in that case, or yeah, so it's going to be like this. So pc dot assign model, and I pass in the particular model that I have. So the model we had was km, which we stored there, right? We store it as km for k-means. Then I can now come back here. Let's store inside a particular variable called km df, right? Km data frame. Then now I can just come back here and now I can check it out. So if I go back to this km df dot head, which is going to generate all the same data that we used, right? Wow, very interesting. Countries, latitude, longitude, then the individual clusters. So you can see from this place that United Arab Emirates and Afghanistan belong to the same cluster, which it makes sense because United Arab Emirates and Afghanistan are actually in Asia. They are in the same continent. Very, very cool and very nice. Now let's see how to plot them, right? So we have seen how to create our model. We have seen how to assign the individual clusters to our dataset. Now let's see how to actually plot them. So I can use a normal single plot, normal scatter plot to help us with that, since our scatter plot was not working. So we can just plot it with our normal plot, which is going to be plot.scatter. Then I'll just go with my df, or let's go with the new one that we have. So km and let's go df, right? And I'll just go straight away. So it's longitude first, longitude, then the next one is going to be for our latitude. So df km, k means data frame, which is going to be our latitude. So latitude, yeah. Then next one is that we're going to specify the c. So the c will be using the last column here, which is this particular column. So this clusters column, right? That's what we're trying to use. Right, so it's going to be my km df, and I'll just go with cluster. And then remember that this c usually take numerical data, so because we are doing it, it may not work. Then let's go with our color mapping. CM map is going to be rainbow. So let's try this one. If you try this one, it's not going to work, right? The reason it's not going to work is that we could not even see it as much as we wanted to see, right? Because the reason is that this cluster, right, the cluster column that we have here is not in numerical data, so we have to convert it to numerical data. So let's see how to do that. So I just come back to the top of this my file, then I'm going to change these clusters, right? So let's create a different copy. So let's go to km df2, which is going to be km, and let's go df dot copy, right? So we are creating a copy, then it's going to be a normal shallow copy. Then I just come back again and I'll rechange this one. So I'm going to change this one. So it's going to be my km underscore df, my cluster, the cluster column that we had. So cluster, right? I'm going to equate it to this option. So let's copy this one here. and then just come back here and then equate it. So we are equating this one. You're going to be splitting, you're going to remove all of these clusters from it so that I've left with only the numbers. So it's going to be string dot, let's come back, string dot replace, can't spell replace, replace, right? I'm replacing the cluster with an empty stuff. Then whatever I'm going to get, I'm going to go with apply. I will apply into it, so it's going to convert it to integers, right? So let's try it out. Hopefully it doesn't give us any error. So perfect. If I go back again to kmdf2 dot head, now that column for the clusters are, for now it is only numbers, right? So now we can actually use it in our data set. So I can just come back here, change this one to 2, change this one to 2, change this one to 2. Now it's going to work perfectly without giving us any error. So I run it. Perfect. It's going to generate our plot for us, which is very nice and very cool. So if you look at this plot, it looks like this place is like Africa-ish, this place is like South America. It looks like the world map, right? So you can actually overlay it to our general map that we have. So that is how to work with it. So based on this, you can also see that it gave us some colors. We have some red, 1, 2, 3, 4, 5, 6, 7, right? So about 7 different colors for the 7 clusters. And then since these colors are almost the same, that means that some of the data set, if you plot it on the map, it may look some different way. So that means that you have to scale them, but I don't see the point of scaling them. You have to use maybe a main mass scaler to help us with that. So let's go back and then let's see how to overlap it with our GeoPandas. Then later on we'll see how to predict, right? Make some predictions. So this is going to be our overlapping with GeoPandas, right? So I'll just first of all import GeoPandas. It's going to be pip install GeoPandas, and then this Catis, right? GeoPandas, and then this Catis, right? So these are the 2 main packages that you are importing. Then you use it to help us with that, right? It's going to download it. It's already installed. And use it to help us with that. So whilst it's doing that, we're just going to go with import GeoPandas, right, as JPD, right? That is the most important thing. Then you're going to import this Catis to help us with that, right? So these are the 2 main stuff that we are importing. Perfect. And then now the next thing we need to do is we're going to create our world map. We are going to get our world map from the GeoPandas dataset. Then later on we're going to plot our map and then overlap it, right, with it. So let's come back here and then work on our world map. It's going to be world. It's going to be this option. It's going to be JPD, right? That is GeoPandas. Then I'm going to go with my read file, right? And I'll pass in what I want to read. So I want to go with my JPD again. Then I'll get my dataset. So it's going to be my datasets dot get path. Then I'm going to pass in what I want. So I want the natural resolution. So natural edge low resolution, right? That's what I want. Don't know whether the spelling is correct, right? So there's supposed to be underscore. That is what we need, right? So natural edge low resolution. Then that is all. So we need these important ones. Then we need to set an axis. So this give it as an axis. So the axis is going to be world plot, then figure size. So the figure size is going to be 2010, as you have been doing. You mostly do. Then I'm just going to create axis, going to ax, then let's set it off, right? So if I run this one now, it's going to generate our plot for us. Who doesn't give us any error? Perfect. So this is our world map. So it will be overlapping this thing that we had. This is our scatter plot, which we generated using a normal scatter plot, normal matplotlib, and then which we have our clusters from k-means using PyCaret, right? So we overlapping them on top of it, right? You overlap on top of it to see how it is, whether they are in the right places. All of these things you are doing is just trying to find which of these latitude and longitude belong to a particular continent, right? We are using it to help us label our data. Very interesting. So now let's see how to do the overlapping. So it's going to be, first of all, let's go to G. We convert our data frame into GeoPandas. So gpd.jpandas data frame, right? I'm going to go back to my km df. So you can just use a df1 or df2, any of them is going to work, right? Let's use a df1 or df2, right? So that's what you are using. So that's something very simple. Then I'm just going to give the geometry. So the geometry, just as we have here. So the same thing that we have, that's what we're trying to do. So geometry, right? So let me take off this. Sometimes this one becomes annoying. So GPD points from S and Y. So we are taking the first one. What we are taking for our point is that we will be using the km df using the longitude and latitude to help us with that, right? So it's going to be this option, longitude, just as you are seeing here. So we have x and y, so that's what you're trying to pass there. So we just come back and then we pass in our longitude first. This is df2, that's what you're using. I'm taking some time, apologies for that. So in case you're not subscribed to this channel, you can also subscribe and then check the link below for some interesting materials to help you master machine learning and then Python. Longitude, the next one is going to be km, that's for df2, latitude, right? That is all. So latitude, right? Latitude, that's all. So these are the main ones that we need to help us with our plot, right? So let's run it. Hopefully it doesn't give us any error. It's giving us an error because so syntax error because we not close it all. So let's close it. Let's run it again. Right, perfect. So now if I go back and I check the G that we had, so now it's going to give us, convert our latitude and longitude into their normal coordinates, right? Very interesting and very simple. So longitude and latitude, very nice. Now we can actually plot this one. So let me create some space and then we do our plot, right? So I'll copy it and paste it to save us time, otherwise it will be the same thing. So the basic thing we are doing here now is that we are just going to copy this thing above, the same thing that we did here, this plot that we created, and then work on it, right? That's the basic stuff we are doing. So I'll just use that one to help us with that. So it's taking some time. So our destiny was this one, it was G, right? So we are just going to overlap it and let's see what you're going to get. Voila, right? So you can see that now it has overlapped it in a very nice way, but some of them are far away. So these ones looks like, I don't know what these countries are, and then some of them are in the right places. See that, you can see that this is South Africa, and then this is Australia. Some of them are in the right place. We have seen how to overlap them, right? But we can actually scale them to make it look better, right? But this is okay, right? That is how to actually use PyCaret clustering, k-means clustering, to help us to be able to plot, right? Be able to get the right labels for these particular ones, so we can now map them all. So we know that these ones belong to this particular cluster, and we can find a particular cluster, the content, then you map them well, right? That's the basic understanding behind that. So let's see how to do a simple prediction with what we have done so far. So we're trying to predict with this, right? So let's try it out. So we have seen how to work on it. So if I go back to this km df, right, that we had, so this is what we were using. So we'll be trying to see whether it will be able to cluster, put them in the right cluster, right? So I'm going to pick any country. So let's pick a country like Ghana, right? Everybody likes this country. Or let's pick a country like maybe India or something, right? Or any other country that you want to pick. But we have already chosen some latitude already. So this is the latitude you have chosen. I want to predict and see where this particular latitude is. We may not know it is an unknown data. And in trying to make some predictions, the best thing you should do is that you should convert it always into a data frame for it to before you can supply to PyCaret, before it will work. So let's check it out. So this is going to be our unknown data. Let me clear up these ones. So this is our data, right? They are trying to check. So now I'm going to send it to my prediction, my model. So it's going to be predict. We're making a prediction. So to make a prediction is very simple. So let's go as my cluster predictor. So cluster prediction, right? Something like that. The particular kind of cluster that is going to be. I'm just going to go with my pc.predict model, right? Then I'll specify the model I'm using, right? And then the data. So the model I'm using is a KM model, k-means model. Then the data is going to be the unknown data that we had, which was going to be our data. It's called to my unknown data, right? Unknown data, which we know that it is these particular characters, right? That's what you're trying to do. If I run it, it's going to analyze it and give us a data frame. It's going to return a data frame. So if I go back and I check it back again, so this is going to be cluster. Yeah. If I check it now, it's going to give us the right cluster. Very interesting, which is cluster 3. And then that is the right cluster. And then if you check this particular latitude that we have, longitude, the latitude and longitude of this particular stuff is actually a simple country which can be found in cluster 3. So let's check what cluster 3 has to offer us from our data set. So I'll just go back to the same thing that we did. Then we will just go back to this place. We have KM DF, right, cluster. So let's go with, which is going to be is equal to cluster 3. We want to know the particular country, or the particular, not the particular country, but the particular continent, right? So I'll just go with KM DF, right? Now pass it here. So let's check it out. It's going to get all clusters that are belonging to this particular cluster. So you can see from here that this is Sierra Leone, Senegal, Chad, Togo, Tunisia. So that means that our cluster was our longitude, which was this particular longitude that we have here, right? The one that give us this particular longitude, this unknown longitude and latitude, belongs to the cluster 3, which cluster 3, as we know from these countries, is in Africa, right? So Cote d'Ivoire, Cape Verde, and then if you check it, it's the same. The latitude is this one. These are the values. So it was actually Ghana, right? So Ghana is actually in Africa. So that is how to use unsupervised machine learning using PyCaret and clustering, using k-means clustering to help us to be able to label our data sets, right? To label them, a data set here, which consists of countries, their latitude and longitude, to label them to their respective continent. So thank you for watching this long tutorial. So the basic understanding behind this is that first of all, you just have to install the necessary package. Then you create your model, you assign your model, then you can do your plot, whatever plot that you want to do. Then you can make your predictions, then you can save them. So thank you for watching this tutorial. See you another time. In case you have any question or contribution, you can just post at the comment section below, and then don't forget to subscribe and click on the notification button. Thank you. See you another time. Bye.